Hi, this is Shane Mueller, and this is part one of a screencast covering the materials in chapter one of this textbook, Applied Statistical Analysis for Psychology and Human Factors in R. And this will be just part one, which gets your feet wet in the statistical tool called R. So there's a lot of different statistical stats packages available of different levels. Some are very simple, some are very complicated, some have a lot of power, some don't, some are free, others cost a lot of money. And the one that I use for this book is called R. And R is a free open source tool to do data analysis, data visualization, a lot of different analytics, and it's a really useful platform for handling data. Maybe a little more complex than a lot of simpler tools that let you do simple analyses, but it supports a lot of things that are critical for data analysis that many other tools don't, including things like data handling and recoding and programming and things like that. So because of its power, it's become one of the de facto standards for implementing new packages by researchers working in fields of statistical computing. And there are thousands of packages out there to do almost anything you want. And although at one time R lagged behind its commercial competitors, probably with the packages available, there are many things that you can only do in R. So this screencast just covers the basic tool called RStudio. RStudio is built by a commercial company, but it's given away for free. They also sell a support for it and some other things that you can do with the commercial version. It runs R within it, and so RStudio doesn't make R itself. It simply packages it, and it pays for and contributes a lot of the most popular packages for R for doing aggregation and data visualization and databases and things like that. So you first need to install it, and you may need to install R. And here I have 3.5.1 installed, which was released in 2018. And you need RStudio. And if I look here, I can see that RStudio is 1.1.456, also from 2018. So this is just to walk you through some of the main pieces of RStudio and how to use it and what things are good for. Oftentimes when you open it up, there will be a window up here, and so I'll open a window up there and I'll tell you what it's for in just a bit. Well, there's a lot of different parts here, so let's cover each one. This terminal is actually brand new, and I won't cover it because it's pretty advanced. But this, what's called the console, is the main sort of way you interact with R. So R is here. This little light thing is blinking. The cursor is blinking. It's waiting for input. And when you type input, it processes that input and produces a result. And at its heart, it's just a calculator. So you can open this and type something 3. Well, if you just type 3, if you tell it 3, the result is 3, and so it returns 3. But you could use it for math. 3 plus 4, that's 7. 9 point. You can see you can use it for really complex just calculations like that. And so it's at its heart, it's a calculator, and it can do math on numbers. But But if you only interacted with R with this window, it could get quite tedious because sometimes you screw up and you want to do it over again. Sometimes you have a lot of analysis and you want to change one thing. You want to be able to save things, and that's where this window comes in. So traditionally, people would save a set of commands in a file, and these files are usually saved as a R file. So if we save this and I say test.r, now I can type anything in here, even if it's not legal R, and I can save it in here, but you want it to be legal R code so that you can execute this. So maybe you have a series of numbers you want and calculations you want to compute, and so on. And there's a few ways, I'm going to save this, there's a few ways that you can manage this. One is you just use this as sort of a notepad, and so I do this and I can hit on Windows and Linux, I think it's Control Enter. I guess it might be Command Enter here or Control Enter. So if you hit Command or Control Enter, it takes whatever's on that line and sends it down to this console. So 32, and now if we do 3 minus 4, you can see it sent 3 minus 4, and the answer was given there, and so on. So you can do one line at a time, or you can use some of these run commands. Run will run one line at a time. You can see if you hover over it, Command Enter, rerun the previous code, and then, or you could source. Source sends the whole file over, and I guess it kind of depends on what platform you're on. It looks like on Mac OS, it has this echo equals true, so every single command was sent, but maybe we can source without echo, source without echo, and actually it ran all of these, but it didn't display anything. It didn't output anything. So although it computed it, there's no way of telling. But if we had some type of side effect, we'd be able to see that. There are other types of files you can use up here. One of the most popular are Markdown and Notebook. Notebooks are very similar to Markdowns, where you create a document that does the calculation within the document and creates maybe a Word file or a web page. And so you can sort of do the analysis and create a report. If you change the data, you just rerun this Markdown file. All right, I just had to find a data set. So you will often have one or more data sets loaded that you're looking at, you're trying to do analysis on. And so there's a bunch of built-in data sets, and so we can load one with iris, and then if I just like when I typed A, I could type iris, and now it prints that out. But you can also look at iris in more of a spreadsheet format by clicking on it over here. That data now appears over here, and we have a bunch of variables that are recorded for each observation of an iris. And there's other things you can see. You can sort by different values, and you can see what type of data it is, do filtering and things like that. So that's another view that you can access. And in fact, if I click on it here, you see how down here, just this command view iris is sent. So I can use view iris to open that up. Over here is the workspace or environment. This lists all of the data that is available. In many stats packages, especially simple ones, you can have one data table open at a time, so one data set. But that's not true of R. You can have as many as you have memory for, and probably even more if you manage to save things out onto disk cache or something. So generally you'll have many different data sets, maybe from many different projects that you'll have access to. And this can be difficult because you might have more than one data set available, but it also means that you can take maybe your raw data and then filter out um, certain trials that you don't, or certain observations that you don't want to use, and you can jump back and forth between them really easily. This is the way of seeing the name of what everything that's available. There's also ways of doing different environments that can be pretty advanced that are often used for specific packages. Over here there's also history, and so you can see all of the commands I've written are here. If you're running a series of steps and you found something that worked and then you tried something else and that didn't work, you can go over to this window to get back to the last thing that you want to try. And I could take this and send it over to the source file, or I could send it to the console, or I could save this whole thing. So if I do a bunch of analyses and I said, hey, that worked, I could just go over here, save the whole thing, and then open it here and edit it for later. So that's history. Now over on the, so that covers a lot of what's in here, here, and here. Over in the bottom right are another set of tabs. There's files, which I've never really used, but can help you find specific files to load, just like the Windows Explorer or Finder might. There's a plots that we'll look at in just a second. There's packages, there's help, and there's a viewer. So plots is where if you're using just the standard R file and you create a plot, then the plot will show up there. So if I plot, an easy plot to do is histogram of R norm. You can see that the plot shows up over here, and I can zoom in to bring it into a larger window. I could export it as a PDF or an image or a copy to clipboard. I could remove it if I don't want it. I could clear all my plots, and there's actually ways to sort of publish this live to websites as well. So files, help you look for files. Packages is how you load new packages, and throughout this course we'll be using a lot of third-party packages that you'll either have to look through and load, or you'll have to install. You can install them through this button, or load them by just, say, clicking on this, but you can also load them with a command in this R file. The other thing is, this is a handy way to find the help. If you're using some type of package and you want to see how it works, you can click here, and all of the help files will show up. In fact, that's the last panel here is help, to help you find how things work. And if there's a command that you don't know how it works, you can always type question mark. Maybe we want to see how hist works, and then the help file for hist or histograms will show up, and it will give you details about how to make the format the function and what all the arguments mean and what the output what output will occur. Let's see. That's a lot of what's here. There's also, I guess, the last piece is these projects, and this a lot of people don't use these, but this is a way of binding both these data environments together with a file, so that you can they're portable, and you can sort of create a saved version of your analysis and close everything down and open it up even years later and continue working on it. Okay, so this is the basic setup for R, and so one of some of the things that I like about R is that it can be very expressive. You can you, when you are doing an analysis, you save the sets of commands one by one, and you can try these out, and you can layer things on top of each other, so it's really flexible. Another thing that's nice is that it's portable. I have um, I have analyses that are 10 or 15 years old that I sometimes might go back to, and they will still run without any trouble because I have all the sequences um, of commands. The way I typically use it is I load a data file at the beginning of one of these files. I do all the analyses, and then I produce the output. So if necessary, I have all the pieces for the analysis, and I can run the whole thing again years later. A couple things to think about is that when R is running, it's looking somewhere. It's looking for files to save files or to load files from a specific place on your computer, and that's called the working directory. So if you are looking for a file to load, it's going to look in your working directory. A handy way, what I usually do when I have a file is I will go to the session and say set working directory to source file location. So now it does the set working directory command to wherever I happen to be, which is in this module 1 subdirectory. And now if I do anything, I've saved things out or I read things in, it will read it from the same folder as this is. Some people like to do in this file, do something like set working directory to put that command there. And let's see, something like that. And that's fine, but it can be it can be difficult if you want to give your analysis to someone else because their working directory might be a completely different spot. And so you're often your best bet is to use the interface to set it to wherever you're looking. I don't know. I don't even really know where it starts. Maybe in your home directory or something like that, or your desktop. So so that you always have the right spot. Another thing to note is that R is case sensitive. We've only looked at a couple functions, but we did a hist of R norm 500 and hist of R norm 500 won't work. Could not find function hist. So be careful about capitalization. It matters almost all the time. Most built-in functions to R are lowercase. Some libraries might have uppercase functions, but most of the built-in functions are lowercase, so you usually can try the lowercase versions. Let's see. Okay. So I'm going to jump ahead to section 1.3.1 and go through some of these exercises. But that's the basic overview. So, okay, so first of all, we talked about simple math calculations. If I can use this as a calculator, 3 plus 3, that turns out to be 6. You have to think about sort of order precedence of operations. So for multiplication, it's doesn't matter which order, but for things like plus, it will multiply. This matters. The order matters, so it will multiply before it adds. So if I do a plus and then a times, it will do a times first here. It did this times first here, and so you get So you just have to be careful that it works like like most modern calculators will, but it doesn't sort of do each one immediately. If you divide by 0, it gives you this number, inf, which stands for infinite, because the limit is any number is divided by something very small goes to infinity. You can also have negative inf, that's negative infinity. And you can actually test for something whether something is infinite with a function called is finite, or you could use is infinite as well. So 3 over 0, that's false. So that's not finite. And you can ask, is it infinite? Yes. So if you're worried about getting stuck by dividing by 0, you can always do a check testing for that. All right, so exercise. Here's an exercise. Use the calculator to multiply your height in feet by 12 and then add the inches to get the total number of inches that you are in your height. Then take that height and transform it into meters. 1 inch is equal to 0.0254 meters. So try those exercises. Try to compute the average height in meters of at least 3 people using the same calculations. Just to get exercise using this calculator. Okay, so so far we've been dealing mostly with numbers, but in fact a number is not that handy for data analysis because oftentimes you have a series of numbers. And actually, if you look at just typing a number, you see this little 1 appears here, which tells you that actually this is not just a number, but it's a vector. It's a series of numbers. It's treating it as a series of numbers, but that series of numbers happens to be only 1 long, and the 1 tells you the thing right next to it is the first thing in that list, in that series. You can create a vector of numbers or an array using the C command. So if you put different numbers in here, now it'll print this out as a set, and there's still that 1 there indicating that this 3 is still the first thing there. I could look up what C means, combine values into a vector or list. Okay, so there's a lot of different ways you obtain sequences of numbers. You can read them in from a file, you can compute them, and things like that. If you want a sequence of numbers sort of in order, you can use the colon command. So this will give us 1 to 20, 1 to 50, and you can see if I do 1 to 50, I get this 1 here that tells me this guy's the first one, and then I get this 26 here which tells me this guy's the 26th one. So that's all these bracketed 1s mean. These bracketed numbers just help you when you print it out to see which element it is. So let's think about graphics. There's a set of let me copy some commands up here straight from the book to help make graphics, and I'm going to, so I have these commands. In the book they had these little caret signs because it was, from this console, so I have to delete those because when you try to save it, it doesn't understand those. So I'm gonna select this block of code and hit Control Enter. It's going to send it all over and create this 3-panel graphic. So what we did was we exercised a few additional functions within R. The first one is this PAR function. That stands for parameters, and this is sets graphical parameters, and by default you have a single panel graphic over here, but this is a way of setting multiple graphics. And one thing you can see here is that within PAR I have this MF row is equal to something, and the thing it's equal to is actually a vector that goes 1, 3. MF row is an argument to the parameter function, and for R, when you have a function, it has a series. It can have a series of arguments, values you give it, and those arguments are named, and they often have default values. So if they have a default value, you can you don't have to put it in there, but this allows you to write a function with the arguments in any order you want. You can just by naming each of them, and but like here, the RUnif has an argument called n that, because it's the first argument and it's required, you don't have to actually name it. So you can optionally name these, but you don't have to if you do use them in the order they're defined. But so it looks like these two are two different things, but they're really the same thing. It's that the arguments of a function have names, and usually the first couple, if they're required, aren't if they're required, you won't need to name them, as long as you use them in order that they're defined. And we can find the order they're defined if we do question mark RUnif. You see here that RUnif has n as its first, and then a min and max as optional second and third. So I could do RUnif. If I tried doing RUnif, it'll give me an error, and I could say n is equal to 10, and what this does is gives me 10 random numbers between 0 and 1, which are the min and max. Or I could say 0.5, 1.5, and now these are min and max between 0.5 and 1.5. And I can even do max is equal to 1.5, min is equal to 0.5. So I can change the order as long as I name them. If I don't name them, it will treat 1.5 as the min, 0.5 as the max. I'm not sure what it will do. Well, it can't sample values with 1.5 as the min and 0.5 as the max, so it gives me this warning. So there's a lot of different ways you can use or ignore arguments within a function. So this argument sets up the screen, so it lets us plot three things. Here I sampled 100 random numbers, and here I plotted those numbers. And you can see that we have index along the horizontal axis, and each one of these is the actual values. If I type x, you can see the first one is 0.07, and probably it's this one right here, 0.07. Bar plot is a different function that takes data and draws vertical lines up from 0. And hist is another one that plots a histogram of how many elements are within each bin. Okay, so those are some graphics. Plot, all of these different arguments are really handy when you're plotting things, because there are a lot of different parameters that you might want to set for plotting. You can imagine you want to change the size of these, or the color of these, or the shape of these. You want to change if there's a box. You want to change the header, the titles, and things like that. And all of these will be available through different arguments to the plot command. I'm going to change this plot back to a single row column. I'll hit Control Enter. I don't know what went on there. Set the parameters back. And then I want to look at another data set that's also 100 long. And so I'm going to do that. Let's see. I'm going to paste this from the book up here, and I'm going to create, we'll call it temp, another 100 values, but this time they're going to be, because I took those values between 0 and 1 and I multiplied by 0.2, they're all going to be between 0 and 0.2. I could have used the min or the max argument to do that as well. And then it turns out that even though we looked at arithmetic with pairs of numbers, but even though this is actually 100 numbers here, and this is just one number, it knows what to do here. So it's going to multiply each element of this by 0.2. I could also use add. I could take temp and add 3 to each one. So if I look at temp 2, you can see that all of them are above 3, but they're all between 3 and 3.2. Maybe I'll now take and make y, which is going to be x, this thing we created before, and adds this temp value to it. So you can see that this is a 2-character, it looks like less than dash, it's arrow. This is an assignment arrow, so many programming languages would use an equal sign there, or maybe a colon equals in some languages, and R traditionally uses this to indicate assignment. And it's handy to use this because it prevents you from confusing this with a test for equality. If I want to know if 3 is equal to 5, you need to do a double equals in R. However, people didn't like this after years of it being like this, and so now you can use the single equals sign in most cases as well. So a single equals sign is an assignment, and it's identical to this arrow dash assignment symbol. But be careful if you use this that you don't confuse it for this, because these are two different things. Like I could do this, and I won't. If I say if instead I said is y double equal to 5, I get a test for each element is if it's whether it's equal to 5. It doesn't, and y doesn't change in that case. So I've got an x and a y, and that plot function we used before can plot x and y against one another. And it looks like a pretty high correlation, but not perfect because I added this other stuff into it. Another function you could do would be core, which asks what the correlation is. And this won't plot anything, but it will produce as a result the correlation. And then, or I could also say, assign that to a value. Okay, and that nothing shows up here, but now if I type, actually if you look up here, xy core, the value is shown, or I could type xy core, and I get the value. So one way you could use this is you could plot x and y, and I could say main is equal to, maybe we round xy core to 3 significant digits. And so now the correlation is shown here. Main is the argument of plot that tells you what to put as the main title. All right, so so this shows how you can manage a vector, but there's a lot of different ways you might store data, not just as a vector, but more as a table, sort of like this iris we saw here. There's a few different tables. There's actually something called a table and something called a tensor and something called a matrix and something called a data frame. And over time, we'll use all of these. A matrix is just like a vector, and you create it like this matrix, and then I'll just use this RUnif 100, and then you tell it how many rows and columns you want. And I don't know which one is the rows and which one is the column, but we can check that by looking at the help for matrix. Matrix looks for the data, then the number of rows and the number of columns. So I could do like this. Now if I look at M, you can see it's got 10 rows and 10 columns. Or if I wanted 20 rows and 5 columns, now you can see it's got 5 columns and 20 rows. Now this is a true sort of mathematical matrix. Every element has to be the same type. They all have to be numbers. We could, and doing math on it works just like doing math on a vector. You can do matrix multiplication and vector multiplication with vectors through various commands, and this tends to be very fast. If you apply a function to the whole thing, so I could round it to 3 significant digits to get a better output like this. And so on. Now I may want to access parts of this matrix. Oh, actually, so that's what a matrix looks like, but that's inconvenient for a lot of types of data. If you have a data set, maybe your first column is a person's name or subject code, which is not really a number. Maybe your second column is their gender, which is going to be coded in words, male, female, or other, or something like that. And then you'll have, sometimes very qualitative data, categorical data, and numeric data all mixed together. And a matrix can only handle one type. But so if you want to bind together multiple types of data, use a data frame. And we can convert a matrix to a data frame, although there's a lot easier ways to get data frames. But we can look at it just here. So I'm going to use the command as data frame and plot and print that out. And you can see that now it looks very similar, but it's got labeled columns. So if I assign this to the variable n, and I can now there's several different ways of accessing this information. So a data frame is a lot like a matrix, but there's some ways it's different. So first of all, whether we have a matrix or a vector or whatever, you sometimes want to access just one element of it. So if we look at y, we want to say, well, I want to get the 17th element of y. We already know it's going to be this one, so we can check. You can use y and then bracket 17, and it will pull that one out, or y 99, and you can access a set of them, 1 to 10. So this just pulls out the first 10. So the bracket lets you access sub-elements. The same is true for matrices. So we've got this matrix, but now we have a row and a column. So we might say M1, if I want to get the first row and the second element of the first row, you can see that that gets this guy. But I can do ranges here too. If I want the whole first row, I can just leave the second thing blank. If I want the whole second column, I can leave that blank, and it will do that whole range. Or I could do a specific element. And now for n, now imagine these are different variables. You know, how fast are you? How tall are you? I can access these directly with the $sign. Now we have 5 different variables that were automatically named. There's ways of naming these yourself. So I might want to look at the third one, and now I've got a vector of just those values. So that again is pretty handy to be able to store everything together. Of course, for n, normally I can do the same matrix notation on data frames too. So I could look at n1, and this tells me all the values for the first participant or for first observation. Or I can look at comma 1, and that's just like accessing variable 1. So I could look at all the values across people for one of the variables. One thing that is nice about data frames is they can easily be added to. So I've got n, and have these variables. So if I want to say n study, maybe I have, here's one study with 20 observations, and I want to call it study 1. Now if I look at n, it's added that single value to every row of study 1. Now it could also add 20 different values, and it will do that. Or there's a lot of different things you can do. If I just get, what happens if I just give it 2 values? So I just gave it 1 and it repeated it. Well, if I give it 2, it's going to repeat those as well. So what it does is it recycles. If you try to do an assignment or test the quality of things that are of different length, if it doesn't, many times what it will do is recycle and just keep going through. So sometimes you have an experimental design where you go through different conditions, A, B, A, B, A, B, and this would be an easy way to put that in your data. So in the book, there's a number of other ways that it looks like that it shows you to manage data frames. For the most part, we are going to be dealing with data frames when handling data. And a single data frame is sort of like what might be a workbook in Excel, or a data set within SPSS, or another data analysis system. But now you can see here, if we go up here, I've got under data, I've got iris, which is the demo I showed you earlier, and M, which is the matrix, and N, which is the data frame. And if I click up here, I can look at it here. So you can see up here at the very top what your real data is. And then along the way, I have a bunch of other things I've demoed here, but these could easily be separate, like sub-analyses that I do on this, that I create little things to help me plot things well or do other types of analysis. All right, so this, just to summarize, this was an overview of Chapter 1, basically up through Section 1.5 of the book, so Part 1 of Chapter 1. And the rest of Chapter 1 will be in a separate video.